All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue working on the sliding window logic. So I don't know if I um, realized this on stream yesterday or if it was after stream, but somewhere in between yesterday's and today's stream, I did realize that I'm gonna need a custom sliding window function because my sliding windows are not going to be based on indices. They're going to be based on the time. So while sliding windows would usually have fixed lengths, fixed sizes, and you would slide the window element by element, or you could like create a stride as well if you wanted. In my case, it's not going to be going element by element. I mean, it will be going element by element, but the size of the window would be the size of the window and the stride would be based on um, time, or more specifically, based on the value that's in one of the columns. So the first thing I did was create a data frame out of the dictionaries that I had, because the transcript gets returned as a list of dictionaries, and each dictionary contains a start time, an end time. That's basically the timestamps, and also the text. So that's the text that's being spoken, I guess, created, said. That text is basically what's being said within that time frame, the time frame that's specified by the timestamps. So we have a list of dictionaries like that, and each dialogue is a separate dictionary. So I figured it would be helpful, especially if I want to be able to use pandas like operations. And pandas does give you a lot of a lot of ways to work with data, so it definitely makes sense to convert the data that you have into a pandas data frame, so you can then operate on that data. The good news is that I don't need to change any data in this data frame. I only need to read the data. That does simplify things. um, I mean, there's still, some sophisticated logic I'm going to have to come up with for various things, but it does simplify things greatly because I don't have to edit that same data frame. Any new data that's going to be generated, it's going to be in a new data frame. And in terms of views, because I'm going to have to create windows, right? I need to see how I want to go about um, setting up the concept of windows. Yeah, okay. I think I can ask Gemini. Hold on, let me open up a new conversation and let me explain the situation. Okay. I'm gonna okay, so in pandas, no, in Python, I have a pandas data frame. Um, Let me just describe it instead of typing it out. I have a pandas data frame with three columns, A, B, and C. Uh, Column A contains values 1 to 10. Column B contains the same. And okay, A, B, C, D, E, F, G, H, I, J. And column C contains the strings, contains contains characters A, or let me say alphabets. Alphabets A to Z. Um, no, A to J. Um, are you able to visualize this data frame so far? Because I have some questions about this. If you're able to visualize it, kindly print out the data frame for me. Okay, I've got a clear mental image of your data. It looks like a tidy 10-row table where columns A and B are acting like twins, and column C provides a nice alphabetical label for each row. Okay, that wasn't the intent, but okay, all right. Since you're likely working in a Python environment like Jupyter or standard IDE, here is how the data frame would look when printed. Yep, okay, that's exactly what I was imagining. That's exactly what I was thinking. Uh, I could I could drop it here. Actually, do I have a Scratch file? I think I have a Scratch file. Scratch notes here. Um, Real quick because I'm not sure what it's going to end up pasting. So give me a second. Okay, it pasted the CSV. So this is our data from the data frame. There's 4 columns here because one of them is the row index. I forgot exactly what it's called. It's like an index column or something. It's not part of the data frame, or it's not meant to be part of the data frame. It's not meant to be part of the data of the data frame. Okay, quick code reference just in case you need to recreate it. Yeah, that's okay. That's all good. Wait a minute. I didn't know this was a thing. String ASCII lowercase. Back up, dude. Back up. Um, where? Here. So let's. Oh, we don't. No, we don't need to do that. We can just do this. Um, okay, so let's say sum O1. Oh, okay. I accidentally hit uh, my pop filter. Okay, sum O1 equals, what was I going to do? Oh, yeah. String dot ASCII. Okay, string is probably not added. Um, Organize imports. Man, I was hoping it would give me an option to, okay, wait. String dot, is it string or is it str? No. String dot, okay, now let's see. Fix all auto-fixable problems. What did it fix? I don't think it fixed anything. Okay, I don't think organize import. I'm trying to see if it adds the string thing, but I guess it doesn't. Let's do import string, and then now we should have access to it. Yeah, ASCII lowercase. I didn't know that this was a thing. What does this take? There is no IntelliSense for this. Oh, this is not a function. This is not a function. Okay. And when we index it like this and then print it out, this gives us, yeah, there it is, down. A, B, C, D up to J. I didn't know this was a thing. I'd been looking for something similar to this in the past where I could like specify a range from like A to Z. Uh, it never occurred to me to try and do ASCII. But what's interesting is, okay, what exactly does, okay, what would, because we are accessing this as a range. So are we looking at what are we, oh, is it just a, what do you call it? Is it just like, hold on. This is just a string because it does say literal string, doesn't it? It says literal string. So is this just a, uh, let's do ASCII lowercase, print it out. Oh, okay. That's why it's that simple because it's just a string and then we are index, sorry, we are slicing the thing similar to how we would slice a list. Okay, okay. Anyways, back to what we were doing. Uh, right. My question. Okay, so my question is this. What was my question gonna be? I forgot what the question was gonna be. It was something about sliding windows. Oh, yeah. Um, I'm gonna be creating a sliding windows um, functionality. Actually, maybe I shouldn't do that. No, hold on, hold on. I'm gonna change things up a little bit here. What I want to do is print start list up to 10. Okay, and now let's copy this. Hey, sorry, I have a change to make. I want you to set the values of A to this. No problem at all. Adjusting the data is the easy part. Swapping those integers for floats gives so and so, so and so, so and so. All right. Okay. Just a second. Back up. I have Papa Mutt's stream on in the background just so I have some background sound. Um, and he's getting his pirate on right now, so he's yelling. Oh, give me a second. I just realized that I don't have my, what do you call it? I don't have my stream open, so I cannot see the chat. So give me a second while I open up my stream, and we are good to go. All right, so I plan on making um, a sliding window sort of function which calculates sliding windows to get views into the data frame, but those windows would be, but those windows would have boundaries like, why was I asking this question? I completely forgot why I was asking. I wasn't asking because of like, oh yeah, yeah, I need to, dude, I need to remember this. We'll have boundaries like 0 to 2, um, 2 to 4, um, 4 to 6, and so on. Oh, actually, I should do it based on the actual values in here. Let's do 0 to 5 and then 5 to this was okay. No, we can make it a 5-second window, or maybe make it a 10-second window. Yeah, so if we do a 10-second window, we'll have this, and then we'll have that. Okay. Would be 0 to 10, 10 to 20, 20 to 30, and so on. Um, I want to create views that can later be accessed. What I'm wondering is, what is the panda's way of storing these views? Is there such a thing? In pandas, the concept of sliding windows with fixed boundaries, I should mention, I should mention that while the windows might have fixed boundaries, the amount of items they might contain is not fixed at all. So it can be variable. I just wanted to put that in there as well. In pandas, the most efficient and idiomatic way to handle this isn't actually to create a list of separate view objects. Instead, the standard approach is to use binning or bucketing to label your data, then group it. Okay, pandas doesn't have a specific sliding window view object that stays live, but it does have powerful tools to categorize rows into the boundaries you described. Dude, you know what I was thinking yesterday while I was working on this logic, because I was playing around with a lot of um, the logic of accessing things within like a range, and then preparing a data set, and then filtering out the data. I also got a chance to explore the query function, because in the past I've for filtering out data, I've mainly used Boolean indexing. I haven't necessarily used anything else. If I have, during the Kaggle thing, when we were learning pandas, during the Kaggle pandas course, um, if I have used any other functions, I've probably forgotten about them. I'm pretty sure, actually I'm pretty sure there were a couple that involved like anonymous functions, or just the ability to pass in functions. I'm pretty sure there were a couple, but like for the most part, in terms of filtering out data, I've mainly been using Boolean indexing because it tends to be the simplest approach. However, it is not the most, how do I say this? It's not the most readable thing. Trying to read the expressions that you pass into it, it can be a nightmare, especially if your data frame's name is long, and then even the columns within the data frame, their names are long. The expressions that you build are going to end up being super long as well. And you have to do stuff like, for example, actually, I can give an example here. There's like, you can see over here, I was doing this. So this is one example of how query can be nice and small and concise. Another, or rather the Boolean indexing way of this is df01, no, trans01 df start greater than or equal to 0, and trans01 df start less than 10. Is that right? Yes, yes, I think that's right. And now if I run this, you can see here's the result. Well, not that last line, but these are the results from 0 to 10 seconds, or well, everything that's between 0 and 10 seconds, but not equal to 10 seconds, less than 10 seconds. Um, yeah, so this is one way of doing it, and as you can see, it's very, very verbose. And here the column names are just start, or the column name, because we are operating on only one column. The column name in this case is start. You might have longer names as well, and then imagine how long this expression is going to be. I've had situations where I had to do Boolean indexing, fairly complex, might I add, fairly complex Boolean indexing, because I was working with a lot of like sales data, and I had to filter out based on various criteria. So I had situations where the entire expression ended up like I had to put it into multiple lines just to avoid like confusion in, when I'm reading it later on. The alternative is to use the query function. Within the query function, you just pass in a query string. This has its own little bit of syntax. I don't know the advanced stuff in it, but like the basic stuff is this kind of stuff. You can use various types of operators. You can have Boolean operators, bitwise operate. Well, I don't know about bitwise, logical, let's say logical. You can have logical operators. You can have these comparison operators, equal to, greater than, and stuff like that. You can have your addition, subtraction, and stuff like that. You can have unary operators. You can have a bunch of different types of operators. You can also, additionally, I didn't know this part, you can specify, so we can say min max equals, actually, do I have to make this a tuple? I don't remember. Let's see. Hold on. 0 and 10. Is this gonna work, or are we getting an error? No, I think we're good. So we can instead specify external variables in this way. I haven't tested this out, but Gemini said that this does work. Let's test it out now. Yeah, it does. It does work. So this is like super useful. This, as you can see, the syntax is very concise. It's a lot more readable. I'm also able to do this very useful thing, which I learned yesterday. I've seen this multiple times, but I never fully understood what this expression means. This is I think it's called a comparison chain, or chaining comparisons, or something like that. And apparently you can chain multiple comparisons. So the idea here is it's gonna evaluate first if 0 is less than or equal to start. That's basically a way of saying is start greater than or equal to 0. Instead, you just do it the other way. So if 0 is less than or equal to start, and start is less than max, or max is 10 in this case, uh, then the expression evaluates to true. And it's basically going to give you all of the rows where this expression evaluates to true. And this is a nice concise way of catching rows that are in between two values. And speaking of between, apparently there's another way that you can go about this as well. It's not showing up here in IntelliSense, but there is a between function. Would pandas give me between? Okay, apparently there is a between function as well, where you can specify the oh, backup. What if I have to specify this, and then I can do, okay, yeah, that's how we have to do it. So left and right, so we can do 0 and 10. And then one more thing was inclusive. So in inclusive, we can mention either both, as in it um, greater than or equal to 0 and less than or equal to 10, or neither. So then it's going to be only greater than 0 and only greater than or and only less than 10, or left, in which case I think the less than or equal to thing, or the equal, the inclusivity for the left side will apply, and if it's right, then only inclusivity for the right side will apply, and then default is both. So we can do, in my case, I want it to be, you know what? Okay, we can do both. It's both by default. Let's try printing this out. I didn't test this out yesterday. Give me a second. Oh, what did I just do? Let's not do that. Okay. So we'll run this, and this would still need to be used for indexing. So we would still need to pass it into this, and then we get the results we are looking for. Yeah, yeah. However, I mean, I'm probably going to be using this at some point later on, but I do like this a lot more, this query syntax, because it allows you to specify it like a query language. So like you're writing SQL, for example. It allows you to specify it in that way. And in the past, I haven't really played around with this too much. If I would have known how to use this in the past, then I could have done like so much with this. But I mean, there's a lot of situations where I can say a similar thing. Um, at the time I didn't know it, and now I know it, so now I can use it in the future. Okay, carrying on with this. Okay, Pandas doesn't have a specific sliding window view object that stays live, but it does have powerful tools to categorize rows into the boundaries you described. The Pandas way, pd.cut. Since your boundaries are fixed, but the number of items per window is variable, you should use pd.cut. This creates a new column that assigns each row to a specific bin. Okay, this is interesting. I didn't know this was a thing. Hold up. Hold up. pd.cut. There's probably documentation. Yes, there is. Okay. So let's read this. Bin values into discrete intervals. Use cut when you need to segment and sort data values into bins. Oh, I was talking about something that I was thinking about yesterday. Yeah, I was thinking about this yesterday while I was working on this solution. Well, not this solution, but like while I was working on the whole like data frame solution. Um, every now and then I should get, because dude, pandas is one of those things that if I don't use it for a while, um, there's going to be a bunch of functionality of it that I forget. Like there's certain types of functionality that I've used enough times now that it they kind of stick. So like I know how to create I know how to create a data frame. I've done that multiple times. I know how to index a data frame. Not all the ways to index a data frame, but like certain ways. I know that you can use .lock for label-based indexing, and you can use .ilock for index-based, or I think it's integer-based. I don't remember. One of those two. Basically, index-based index-based. I think it's integer-based. But yeah, you can pass in an integer to iloc, and with lock you would have to specify labels. Um, what was I saying? Yeah, I know like very basic stuff that I've done multiple times, but there is still a lot of stuff that I sometimes get confused with, or sometimes I'll forget the functionality of certain things, how you would go about doing certain things. I don't work in nearly as many projects with pandas to be able to remember this. Though I feel like that's going to change, especially now, because like this is one project that I'm doing pandas stuff with. There was another project in which I had to create sales related graphs, but I had to first group and process and run a bunch of calculations on a bunch of data in order to um, in order to be able to get the values, or even use the other values or make them usable. I had to do a lot of pandas stuff with that kind of a project. So there was like I did get a fair bit of experience with data handling and data manipulation there. I also had to use it in another project, which was um, kind of like business sales related. It was meant to visualize a bunch of data relating to the business and the business's purchases and their sales, their inventory, their bunch of different things that you can actually like quantify. So I have had like the problem is these are often like one-off situations where I have to use pandas. I need to start doing things that make me use pandas often, because that's the only way that I'm going to remember a bunch of the pandas stuff. And I mean, once I've done a couple of projects with pandas, then it kind of like, sticks in that, oh yeah, I can use this, I can use that, and so and so and so and so. There's a bunch of like understanding that I have to build, and that understanding is only going to be built if I do a bunch of projects with it. Hold on just a second. Actually, not just a second. Give me a couple of minutes. I need to step away for some time and go finish something, and I will be back. Okay, I'm back. Sorry about that. I had to step away for a bit. Um, what was I talking about? I do remember for the second time I was about to talk about um something that I was thinking about while working on this while working on like the data frame logic. I was thinking about like how because I don't use pandas nearly as often. Quite often I'm mainly doing it. I feel like once I start doing more data science stuff and start doing more deep learning stuff in general, once I start doing more of this stuff practically, I'm probably gonna be using pandas more often. I can't say for sure with the deep learning stuff, but at least with data science stuff, yeah, definitely gonna be words definitely gonna be using um, pandas. Yeah, I'm definitely gonna be using pandas a lot more once I start doing more data science stuff. It's just that like, dude, I I don't know. I kind of like branched out and then branched out again and branched out again. We were doing the Kaggle learn data science stuff, and then slowly the interest just kind of shifted towards other things. Though I mean, that's not a bad thing necessarily. It worked out well because I learned a bunch of things. I didn't just like waste my time. But I would like to get back to the data science stuff as well because there was something interesting in there for me. I found something really interesting in with working with data. Like there's a bunch of very interesting stuff that you learn when you're learning data science, and it may not even end up with like you having to um, how do I say this? It may not even end up with you, or in the end, like once you've learned all of it, maybe you might not even necessarily be doing data science activities, whatever those activities might be, but it's very much possible that the stuff that you have learned um, throughout the data science course, you're going to be using it in other places. Because I've had those kinds of situations. Um, learning data science taught me a lot of stuff that I was able to then apply. And I'm not even fully done learning data science, but yeah, learning data science, it taught me a bunch of stuff that I was able to use and apply in a bunch of other situations as well. So, okay, yeah, what I was thinking is every now and then, maybe I could get Gemini CLI to generate 5 pandas exercises for me. Pandas can generate a data set and then generate an exercise or 5 exercises based on that data set. And I can just try to solve those puzzles, those problems. And in that way, I'll be getting some decent pandas practice. I can do this like, I don't know, once a week or something. Yeah, you know what? We could do that. I feel like that would be interesting, right? Five exercises. I don't even know if I'll finish the 5 exercises in one stream or not. But yeah, I could do that. And then I could post it on GitHub. I can be like, Gemini CLI generated these exercises for me. If you guys want something to practice pandas with, then go ahead. I can like I can organize it into, problem and solution. So then people can view the solution if they want to, or they can just work on the problem itself. My thing is not going to be notebooks based, so I'll have to find a different way to do the problem solution thing because I don't use notebooks anymore. Yeah, I don't use notebooks anymore. Aside from when I'm doing Kaggle stuff, I could set up Kaggle notebooks, but then I feel like the um, GitHub route is better, and the bare bones Python route, or I should say the Python script route is better than the Jupyter route, mostly because I'm doing the Python script workflow these days much more than the the Jupyter notebook workflow. Now give me a second. I just need to open something up. Okay, so we were looking into this binning thing. Oh, yeah, I'll have to set up a prompt with Gemini where I can say, okay, you are a tutor, and we are doing a weekly exercise where you generate a data set for me, and then based on that data set, or should I get Gemini CLI to generate the data set, or should I just use an existing data set and have Gemini CLI um, analyze that data set? Like I can pick an open source data set. I could do that. I could do that. I could pick an open source data set off of like Kaggle or something, and then download that and have Gemini CLI analyze that. Or I mean, no, I can get Gemini CLI to make a data set for me, and then based on that data set, because at that point, because Gemini has made that data set, so Gemini will already have analyzed that data set as well. And well, okay, is that I don't know if that's entirely true because I don't know what the creation process is like. So I don't know if after creating it, Gemini still would need to analyze it. Either way, I can get Gemini to generate the data set, and then based on that data set, generate five exercises. Though I'm wondering if I should. I'm wondering if I should. Hold on. Yeah, I'm wondering if I should reuse the same data set because I don't want to generate. Oh, you know what I could do? I could get Gemini CLI to generate the data set and then generate the exercise for me and generate 10 such exercises for me. Yeah, we could do that. We could do that. So I could tell Gemini to um how like what would that look like? I would just say create a list of 10 exercises uh for me to complete to help me practice pandas, right? I'm going to do 10 exercises because if we are anyways, spending our free Gemini CLI resources like requests and tokens and stuff, because we get a limited number of free tokens for Pro, and I'm going to be using Pro to the generate the data set first of all, and then generate 10 exercises based on that. So what I can say is, okay, um, generate the data set and then generate 10 exercises for me, and we'll go through each exercise one by one. Um, where you explain the problem to me, and then I'll try to solve the problem, and then I'll give you my solution, and you give me any pointers on it before moving on. And in between, if I ask you for a hint, then you can give me a hint as well, but you don't have to give me the full answer. I feel like I'll need to create a prompt. I'll need to craft a prompt for this. I have to sit down and think about all the details of the prompt. At this point, dude, prompt engineering is becoming like storytelling, because there's a bunch of details that I have to think about when generating the prompt, which is interesting. Like, it's really interesting thinking about things in this way. Anyways, okay. That is something I wanna look into. Generating exercises. And once I have solved each of the exercises, all 10 of the exercises, we'll move on to a different data set. But what I'll do is that entire batch, that one data set, and the 10 problems, I'm going to bundle them up and post them on GitHub. So what I can do is I can create like a pandas exercises repo. So we can have batch 1, batch 2, batch 3, and people can, use it however they want. Okay, so we were looking into this binning thing. So bin values into discrete intervals. Now, okay, the thing I need to find out here is that, is this a view or is this actually like pulling out the data? So use cut when you need to segment and sort data values into bins. This function is also useful for going from a continuous variable to a categorical variable. For example, cut could convert ages into groups of age ranges. That's windowing. In my case, that's the window. Supports binning into equal number of bins or a pre-specified array of bins. Okay. Okay. Right. Let's look into how to use this. So we do df window pd.cut. Okay, let's see what this returns. So we create at this point I can delete all this. Okay, so let's create a thing called bins or bin. This is interesting though, because like we specify it like this. We are not specifying, this to that and that to that and that to that. So we're not specifying from and to. We are just specifying, discrete values, and then it creates the bins by itself. I wonder what the criteria is that's being followed there. Okay, df window pd cut. Sorry, zoned out. Okay. Df window, create a new wait, it's that simple to create a new column? Okay, let's say df01 equals pd dot. See, this is why I'm saying I need to like practice pandas more, because there's certain things that I just don't remember if I don't use pandas nearly as much. And pandas is an incredibly sophisticated library. There's no way that I'm going to be, well versed in every single thing in pandas, and I'm definitely not aiming to do that. I just want to know about like some of the most common operations that I would be using. Though even there, it's like even that is not very specific, because the most common set of operations you would be doing depends on what you are doing with pandas, because there's a bunch of different ways that you can handle data with pandas, and people handle data in a plethora of different ways in pandas. Some of those ways also involve um, um, like highly optimized operations, highly optimized ways of doing, highly optimized ways of either accessing information or operating on various like series and stuff. Because not everyone is dealing with, not everyone is dealing with 100 or 1,000 or 10,000 rows. There are actually a lot of projects where the data goes well into hundreds of thousands of rows, and sometimes even like a million rows. There are projects like that, and when you load that kind of data into the machine, it's massive. It's massive even for a beefy machine. It's massive. So depending on what you're trying to do and how you're going about doing it, the set of common operations that you need to know, it'll differ. So I feel like I can't really get a fixed answer there, which is also kind of why I don't want to stick with one data set. I want to do 10 exercises on one data set and then move on to another data set and do another 10 exercises in that data set, then move on to another. And the reason I'm doing 10, not 5, 10 does seem like a lot, but like if I'm getting Gemini to generate a data set for me, I would like to, get some mileage out of that, if it makes sense. I don't want to just be done with it in 5 exercises. 10 exercises would let me get to know the data set a lot better. And who knows? I mean, it's a synthetic data set. I don't know if the data set makes any sense or if Gemini is just going to be generating garbage. I'm sure there's going to be some sort of um, what's the word I'm looking to use here? Some sort of like relation between the variables in the data set, some sort of um, link to real life data sets, or the values are going to be similar to real life data sets. I'm sure when Gemini is generating a synthetic data set, it's going to take all of that into account as well and generate it based on that. Um, I forgot where I was going with this. So, anyways, let's So we have A, 1, 2, 3, and then B, 1, 2, 3. Okay. And then here we would be setting not a list, but what does pd.cut return? If we are assigning it in this way and if we are creating a new column, I'm assuming it's going to be a series. So pandas series, um, I don't know, 4, 5, 6. Does that work? I think that works. Okay. And then we print df01 and okay, so it's that simple to just tack on a new column into the data frame. I feel like I did know this at some point, but I just forgot. Yeah, I don't know. I could be wrong. Hold on. Okay. Just a second. Okay. All right. Right. So let's look at pd.cut. What is cut returning? Cut returns a series or a tuple of series. Um, Wait. Okay, there's a bunch of like ors there, so it can return a series, categorical, unknown, ND array, or a tuple, series, categorical, unknown, ND array, or an interval array, extension array, or so and so, so and so. Okay, all right. Well, I'm mainly um, interested in the series. So we are passing in bins, right? We have our data here, so we can just do, wait. We are up to 40, I think. So if I bin this, what's it gonna look like? Let's do trans df01 window equals pd.cut. Um, yeah, what is supposed to go in X? Oh, what we are binning based on. So that's gonna be start, and then bins would be bins. And is there anything else? Right equals false. What does right mean? Hold on. Okay, we can read that later. It says right equals false. Uh, okay, X bins right. Bool default indicates whether bins include the rightmost edge or not. If right equals true, then bins 1, 2, 3, and 4 indicate 1 to 2, 2 to 3, and 3 to 4. Oh, this argument is ignored when bins is in interval index. Dude, there's another thing that I never actually um, got a chance to look deeper into. I did start looking into it, but I didn't really go too deep into it. It's the concept of multi-indexing or multi-index in pandas. I never actually got a chance to look deeper into that. That's also why I didn't really do too much with that whole pivot table thing, because Pivot tables, they apparently give you a bunch of very useful information about a certain data set. But when you generate it in pandas, it gives you a multi-indexed data frame. And so the way to get useful information out of it is to access it in the way that you would be accessing multi-index data frames. I didn't know how to do that because I've never worked with multi-index before. So I wanted to learn how to work with multi-index, but I didn't really, go too deep into that. Okay. All right. Uh, yeah, we'll set this to that. And first things first, I want to print out the length of this because I haven't indexed the thing yet. No, I haven't sliced the thing yet. So I want to see what length is going to be returned. It's 407. If that's the case, then let's do this. Oh, that's cool. That's really cool. Why does it look like this? Why does it start with a, why does it start with a square bracket or open with a square bracket, but then close with a parentheses? Hold on. Is it parentheses or parenthesis if we're talking about one? Yeah, this got me curious. That I just said parentheses, but then usually when I say parentheses, I'm talking about something being within parentheses. I don't know what the, because like I mean I'm used to just calling it brackets. So you have brackets, you have curly brackets, square brackets, and I don't remember if there are more brackets, but that's what I usually say. And parentheses, I picked it up because of programming. The singular form of parentheses is parenthesis. Okay, all right. So it's kind of like axis, axes, um, and so on. Like I also say process and processes. Okay, okay. Anyways, the result here is interesting. And another thing that's interesting is that anything that doesn't fit within the bin, it becomes a nan. The window value becomes a nan. But this is great. This is great because now that we have this windowing mechanism, we can sort of group the values based on the window boundaries, and that's our window. Wait, I just realized there might be a problem because later on I want to do the sliding window thing, but I want to slide from 0 seconds to 30 seconds and still have it be a 60-second window. So it'll be a 0 to 60-second window, and then a 30 to 90-second window. And then, yeah, how do we do that? Yeah, yeah, we need a way to handle overlapping windows here. Give me a second. Okay, let's see what Gemini is suggesting here. Once you have binned the data, you use group by. That's another thing that I haven't used nearly as much. Group by does make certain things easier, certain things that I would have been just using plain Boolean indexing for previously. Okay, this acts as your gateway to access each window whenever you need it. To get a specific window, you Boolean index. Okay, hold on. This is a is this a string? What is the type of? Okay, wait. Let's do ilock 0 um window, and I wanna wait. Is this right? Yeah. Okay. I want to see what the type is over here. Does this return string or something else? Oh, this probably isn't a string. This is an interval. This is an interval. Okay, all right. To iterate through all the windows, Python for within so and so so and so. Okay, all right. What? Holy shit! What was that? Storing for later. If you want to keep these as distinct objects, you can grab by index. You can store the groups in a dictionary and so on. Okay. Okay, here's the thing. What I wanted to do is create windows of 10 values long boundaries, but then slide by five values. I feel like the windowing logic you have provided works well if I don't have overlapping windows. Okay, you are spot on. pd.cut is great for tumbling windows where data stays in its own lane, but it falls apart. Oh, this is great for like creating histograms, for example. Yeah, because in a histogram, you would bin the data first, and then you would create you would then either count those values or add up the values or however you want to go about doing that. But you do something with that group of values in order to control the size of that bin in the bar graph, and then you just plot all of those bars, and you have your entire bar graph. Okay. But it falls apart for overlapping or sliding windows because a single row can't belong to two bins at once in a single column. In pandas, there isn't a single built-in sliding window view object that stores these overlaps automatically. Instead, the most pandas-centric way is to do this is to generate a list of filtered data frames, which are slices slash views of the original. Since your boundaries, hold on, yeah, since your boundaries are 0 to 10, 5 to 15. Oh, that's interesting. Yeah. Yeah, so I can calculate well, okay, I was planning on doing this anyways. This was going to be like my custom sliding window function where I set the boundary. There's going to be an iteration. There's going to be a start value and an end value, and then there's going to be a boundary for the window. So it's like how many values long, or how many values from the min value, and then we'll provide a stride, which would be, if it's going to skip to the next thing, if it's going to like go to the next iteration, how many values it should jump when it comes to the next iteration. Sorry, zoned out. Okay. In pandas, there isn't so and so. Wait, I read that. Okay, the sliding window strategy. Since your boundaries are so and so, etc., we can't use categorical grouping. We have to manually or via a loop define the start and end of each window. Okay, this is going to go through that entire logic. Okay, I can, yeah, that's fine. Okay, hear me out. Is there no way to store a view based on a predefined Boolean index? Actually, there is a way to do exactly that, but it involves a bit of a shift in how you think about storing the view. In pandas, a Boolean index, a series of true/false values, is exactly what the engine uses under the hood to create a view. If you want to store the logic, oh, I don't need to store a view. Why? Okay, I keep trying to do this, right? But at this point, I've either forgotten why I was trying to do this, or I didn't have any plans for this in the first place. Like I didn't think it through what exactly I was planning on doing with this. At this point, I can't remember what it was going to be. Anyways, let's continue, because like if I create the function myself, obviously there's going to be like a loop. Oh, the reason I wanted to store it was so I can calculate the I can calculate what the view, quote unquote, is supposed to be. Oh, the view is the Boolean index. The view is the Boolean index. I can store a list of a list of Booleans. So for every window, I'll calculate a Boolean index list and store it. And then we have our entire list calculated. I can then um, iterate over that list at any time to index the rows that I want. Okay, let me see what Gemini was going to say. Was Gemini going to say the exact same thing? If you want to store the logic of the window without copying the data, you should store the Boolean mask. Okay, yeah, that's what Gemini is also suggesting. I can store the Boolean index itself. Yes, I can store the Boolean index itself. Now this only works. Would I be able to generate? Would I be able to use a query string for this? As in use the query function? Because I think the query function returns a data frame. It doesn't return a Boolean index. Between returns a Boolean index. And technically, I am looking for between. Yeah. Between returns a Boolean index. In fact, I probably don't even words. I probably don't even need to write the entire like for loop, I can probably just do the entire thing in a list comprehension. Probably wouldn't look the best, but like as long as I comment the thing, I should. Dude, no, I should prioritize readability, because if I squeeze the entire logic into a list comprehension and then like a week later I come back to it and I don't know jack shit about what's going on, then it's like it's a headache for me. Though I guess I can decide like once I write out the list comprehension, I can decide if it's something that I feel like I'm gonna remember later on or not. Yeah. Sorry, zoned out. Okay. What was I gonna do? Query. What does query return? Query is returning a data frame. So I cannot use query. I would have to use Boolean indexing here. And this is where I'm glad that I know Boolean indexing because, yeah. Well, to be fair, I think I would have been introduced to Boolean indexing later on as well. Like for example, here we have start. What does add? Well, add is gonna return that. Um, what was the thing between? So Boolean between here returns a series and returns a Boolean series. So I could just use this, or I could create that entire Boolean expression. Okay, let me continue reading this. So the mask storage approach, instead of storing the resulting data frames, you store the true/false arrays. This is incredibly memory efficient because you're just storing bits, not the actual raw data. Wait, what did? Okay, instead of storing the resulting data frames, you store the true/false. Yeah, okay, that's exactly um what I had in mind. Um, yeah, dude. Store the Boolean index, start, end. Okay. Window masks. That is a dictionary. Window masks, mask name. What is mask name here? Window so and so, so and so. Oh, and then we can access it as that. Okay, that's an interesting logic. That's an interesting way to. Though I mean, in my case, I'm not planning on doing a dictionary. I'm probably just gonna go with a list because it's a simpler approach. And yeah, once we've iterated over the entire thing, once we've reached to the end, then we can just assume that we've analyzed the entire transcript. Yeah, yeah. Now, what was Gemini suggesting here in terms of backup? Where's that conversation? Okay, I need to find the conversation. Is it this? No. Uh, Okay, yeah, it's this. Segment the transcript. Create a segment of fixed duration, for example, 60 seconds, overlap to avoid cutting an interesting moment in half. Make these windows overlap. You could create a new 60-second segment every 30 seconds. Okay, all right. Each chunk is now a small document with a defined start and end time, ready for analysis. Score the segments. This is where you'll use the NLP models to find different kinds of quote unquote interesting content. You can run these analyses in parallel or on all your chunks. I should look into doing that. Yeah, I should look into ways to do that because Pandas does um, provide you with the functionality to do this kind of stuff in parallel on like multiple um, pieces of data. But there's a specific way to go about doing it. There's a way that would actually make it vectorized, and there's another way that's just not gonna like that. That's gonna be a much slower route. Okay, the signal. This signal finds moments of high emotion. Okay, a text classification model fine-tuned for emotion analysis process. For each 60-second chunk, run the model on its text. Look for spikes in key emotions like joy, surprise, or even anger, which can be very entertaining. Output: give each chunk an emotion score. All right. So we have emotional intensity, we have topic relevance using zero shot classification or sentence similarity. Then we have keyword density. Um, and then we combine the signals. Right, so there are three different signals. So I'm not entirely sure if emotion intensity or emotion analysis, sentiment analysis is really going to do much in my case because it's meant to be more of like a, um, I don't know, educational or, informative kind of thing. Yeah, maybe I should create a new conversation with Gemini and ask, like, based on my specific type of content, what should I be looking for? In terms of NLP, how should I be analyzing this data? Though, I guess let me continue reading this because I might get more information. So we give each chunk an emotion score. So now we have chunks, right? The chunks are um, wait, this might take a while. Yeah, this might take a while. I would need to. How do I go about doing this? Because like we have the chunks. Okay, for each chunk, I can create a data frame where for each chunk I can store a score. So we can have a sentiment analysis score. We can have a topic relevance score. I need to see what kind of result is being returned here. Like I'm saying score, but like what exactly, you know? So like, okay, we're gonna pass in like, okay, we iterate over each of the chunks. For each chunk, we join the text together, which shouldn't be an issue at all. And then that blob of text, that blob of text gets sent um, into the NLP model, and then that's going to return the result. And then the same thing is going to continue for the next few chunks. And then we get the emotional analysis score. I mean, if we are iterating over, if we are iterating over the chunk, we might as well do all of the operations on that chunk in one iteration rather than having multiple separate for loops to do different operations. That makes more sense, right? Because then I can create three separate lists to store the scores, and at the end of this entire iteration, this entire loop, I can create a data frame that's going to store these values. Yes. Okay. Dude, I'm interested in seeing what the data visualization for this would look like. I'm super interested in seeing what the data visualization for this would look like. So I do want to write this entire data frame to um how would this be laid out though? Like we are assume oh yeah, this would be laid out like linearly, right? We wouldn't be specifying the time, but we would be saying that okay, each chunk is 60 seconds long, and we are using a sliding window of 30 seconds. So then basically we are getting a sort of I can like plot it on like a line graph. Actually, there's a bunch of different types of plotting that I can do there. I should look into the kinds of plots I can make with Seaborn, because I'm thinking of like basic plots, which is just line graph and bar graph and scatter plot and stuff like that. Histograms as well. Maybe a heat map could come in here somehow. Um, but yeah, I should, dude. I need to export the scores that are being calculated. I need to export the scores that are being calculated so I can store them and analyze them later on. Yeah, yeah. Though, am I going to be using it? I don't know if I'm really going to be using that data. I mean, I'll make it and I'll store it, but then I don't know if I'm really going to be using that data. But the reason I'm storing it is because I'm anyways doing the calculation. Um, so I might as well store the data because compute power is being used to, you know, generate that data. So I might as well save it and hold on to it. And I mean, anyways, I have my entire pipeline built to bundle up data. Dude, now the pipeline has become a lot more sophisticated. So I'm going to have to be careful not to mix things up. I need to make sure that I should probably make a note of this as well. I should make a note that at any given moment, I should only be working on one batch of uh, data, on one batch of VODs. So I can pick 10 VODs because, like, in terms of generating the bundle, I have to batch the entire thing. Later on, I can run. Oh yeah, where exactly is that happening? I didn't think about that. Like, where exactly am I doing this analysis? Because if this analysis is being done per um, if this analysis is being done And I mean, this analysis can be done in the metadata stage as well, in the generate metadata stage. And then that can produce an additional file in addition to the metadata file. It can produce this NLP scores file. I need to see what type of information I'm trying to get out of this first. I need to understand exactly what type of information I'm trying to get before trying, because I find myself constantly trying to like batch operations together, and that has worked out well up until this point, up until the point where I knew what exactly I wanted to do. But now that I've gotten to the point where I'm still exploring what I need to do and learning what exactly I need to do, I find myself coming up with ideas for like, oh, okay, maybe I could do that, maybe I could do that. And I need to stop myself from actually going ahead and building something within the pipeline that I'm not going to end up using later on. Because I could create a mess that way. Um, Give me a second. Okay, yeah. So we are reading this. A simple way is to count the number of sentences classified. Hold on. Are the six different tasks that I mentioned up here, are they being used in here or not? Okay, what's the high level overview? Okay, we can think of this as a multi-stage pipeline. Segment, you break the transcript into meaningful overlapping chunks. Score, you analyze each chunk using various NLP tasks to generate signals of interest. Then combine and merge. Combine these signals to find the strongest moments, to merge them into coherent clip candidates. Oh, you know what I could do? I could store clip chunk timestamps. I could do that. Yes, I could store clip chunk timestamps. I don't need to store the text necessarily, but I could store the timestamps. If I store the text, that'll make the data frame very long, and then that's going to be a problem. Though, I mean, dude, if I'm going that, no, I can't do that. I was about to say that if I'm going that route, then why not just operate on the original transcript data frame? But the reason I can't do that is because the sliding window is not implemented in that. So like, as in, how do I say that? The data in that data frame hasn't been generated by the sliding window. What I'm trying to take note of, like with the scores and stuff, is the sliding window. Okay. Sorry about that. I had to mute for something. So okay, score. We generate signals of interest, then we combine and merge, combine these signals to find the strongest moments and merge them into coherent clip coordinates. That is where I'm going to need the timestamps. Yes, yes, good thing I thought about that. Yes, yes. So we don't need the text. In that case, we don't need the text. We do need the timestamps. we definitely need the timestamps there for sure. Absolutely. So sorry. So in that one data frame, we can create the multiple signals. So we can have multiple columns for each signal. And then we can have additional columns that are the results of combining those signals. And then we can select stuff based on that. I need to talk to Gemini about this. Wait, no, okay, let's continue. Let's finish reading this. And if I'm not satisfied with, actually, I'm not going to finish reading the entire thing, but like, if I'm not satisfied with the entire thing after I've read it, then I'll ask Gemini for, I'll describe this entire thing to Gemini separately. I'll mention that, hey, this is the case. I have, I have Twitch VODs. For each VOD, I'm going to split out the audio, generate a transcript from the audio. Based on the transcript, I'm going to run these NLP tasks. And based on what I am able to analyze from the transcripts and the timestamps provided, I'm going to determine which timestamps are considered clippable moments, and then I'm going to slice out those videos from those clips from the the main video file. Um, Considering that my streams are not necessarily meant to be entertaining, and there's no high energy or funny moments, it's mostly informative stuff and educational stuff because it's mostly just me studying things and learning things and building things. So keeping that in mind, what NLP tasks should I be focusing on? Um, Currently, I'm looking into 6 specific NLP tasks. So if you have suggestions for any new tasks I should be using, or if you have suggestions for how I could be using these tasks to, better analyze, then go ahead. I feel like with the zero shot classification, I might be able to get something. Um, the thing is, I would first need to extract topics, and then I would have something to pass in as labels for zero shot classification. Because like I don't know if passing in informative or interesting is really gonna work, or it might. I don't know how it's doing the classification. I feel like that's worth looking into as well, learning how the classification is being done, at least on like a higher level, understanding exactly what it means um, when the model labels something as interesting. Sorry, zoned out. Okay. Coherent clip candidates rank and review. Rank the final candidates and present them for easy review. Okay, so segment the transcript. We've gone over that. Kind of? Yeah, yeah. No, we've gone over that. Now we are in score the segments. So we've looked into emotional intensity, which we'll be using text classification for that. Okay. Then topic relevance using zero shot classification or sentence similarity. Oh, yeah. I need to determine from how long to how long a certain topic is being spoken about. So I can build a map of like discussion, if that makes sense. I can build a map of like, how long a certain topic is being discussed. Yeah, I wonder if I can like create, how would I quantify that? How would I display that? Because throughout that transcript, throughout those chunks, we could have, dude, I might need like a separate data frame for each of these. This is really interesting. I'm excited about this because I'm getting ideas for how I would go about dealing. Because like for each of these things, it generates a score. It quantifies this stuff into numbers. Even when we're talking about labels, the labels are being given scores. So even there, it's numbers. And this is an interesting way to like deal with this kind of data. So I'm excited to see how this goes, and I'm glad that I have the Kaggle resources. So I'm going to be able to do it relatively quick compared to if I were running these models locally. For the sake of having IntelliSense, I'll write them locally, but then the final run is going to happen on the cloud. And I mean, I can load that up here as well because I can set up the Kaggle. I already have the Kaggle notebook set up, so I can do that on stream as well. Yeah. Okay. Then topic relevance. This signal finds moments that match a topic you care about. Tool, zero shot classification. Process, defining a list of candidate labels that represent what you want to find. For example, technical explanation, a funny anecdote, game strategy, reacting to chat. Okay, run zero shot model on each chunk with these labels. Give each chunk a topic score based on the model's confidence for your desired labels. Okay, okay. Alternative, use sentence similarity. You could write a few ideal clip sentences like, I'm explaining how this feature works, or this part of the game was hilarious. Then use a sentence similarity model to score how closely each chunk matches the meaning of your ideal sentences. I'm going to have to find a way to figure out, because, like, okay, we can find interesting moments, but I'm also going to need to figure out a way to figure out um, when a certain discussion starts and when it ends. Like finding, within one or two sentences that, oh, yeah, this topic is being spoken about, that's fine, that's great, right? But what if I'm running the discussion for like a couple of minutes? I'm like talking about it for a couple of minutes, and there's a couple of sentences being said there. I'm going to have to find a way to like group this up and, uh, yeah, dude. How do I like go about this? See, what I could do is I do need zero shot classification, right? I do need zero shot classification. Um, but for zero shot, I need labels. So what I could do is I could run, um, I think text classification or I think maybe token classification. I'm not sure which one it is. I can run that over the entire transcript to generate. I can run that over the entire list of chunks to generate a bunch of a bunch of possible labels, and there's going to be a whole lot of like garbage in there, right? But I can use that to generate a whole. I could use it to generate a bunch of possible labels, and then add up the scores of all the possible labels that show up, and then I'll pick like the 10 most or 20, like the 10 highest most or 10 or 20 highest most labels and use them for zero shot classification. I still need to figure out a way to figure out where a discussion starts and where the discussion ends. I need to think of a way to do that. I think that's where I think that's where an LLM would help. I should probably add that into the prompt as well when I'm um, talking to Gemini about this. I feel like I need to write another prompt. But first I want to read this entire thing because this is one of the things that Gemini has mentioned to me before is that the difference between using a specialized NLP model, so an NLP model that's built for a specific task versus using an LLM for that same task is that LLMs understand context better and they can they understand the before and after of the content better. So like they'll take a look at what's going on around the content as well, not just the content itself, which is why they have like a better understanding of what exactly is going on. And if I ask the question, hey, where does this discussion begin? Or, and there's probably going to be a specific way to go about asking that. But if I ask it, hey, what's the discussion about? Give me a couple of labels for this and tell me exactly where it starts and ends. I could probably get some useful answers compared to using specialized NLP models. I need to involve LLMs into this for sure. Okay. Moving on, keyword density using token classification slash named entity recognition. This signal finds moments of focused discussion. A token classification model, run the NER model on each chunk to identify all named entities, games, technologies, people, etc. Give each chunk a density score. If a chunk contains a high number of relevant entities, example, lots of programming terms in a 60-second window, it's likely a focused, informative. Oh, okay. It's likely a focused, informative discussion. Okay, combine signals and merge candidates. Now you have several scores for every 30-second interval of your VOD. Calculate a final interest score for each chunk. Combine the scores into a single number. You can use a weighted average to prioritize what's most important to you. Okay. Identify hot segments. Set a threshold. Any chunk whose interest score is above this threshold is considered a potential clip. Okay, so for something to be a clip, we would probably need to have multiple concurrent high interest scores or multiple concurrent scores of a certain type of interest. Dude, what if I was able to make this? Hold up. We need to calculate we need to calculate all of these scores and then write them to files and then I can download them and run something locally that lets me visualize all of the data, as in the data for each chunk. I feel like that would be an interesting experiment to set up. Yes, yes. I feel like that would be a very interesting experiment to set up. Yeah, because, okay, then what I could do, based on the scores that are returned, So previously I was planning on like automating uh, the process of, clipping based on whatever, based on the analysis of the scores. I might still do that. Actually, I might still do that. Actually, no, I should mention I was planning on automating the process of generating the timestamps that are considered potential clips. That's what I'm trying to say. But now what I'm thinking is, because we have this whole scores thing going on, and because scores can actually be plotted on a graph, I'm wondering if I should do something manual there, and based on the scores that I'm looking at, I could, well, then like stuff like naming a clip and generating the metadata for the clip, that'll kind of get left out. I won't be able to do that. But it is kind of interesting being able to quantify this quantify the scores of the transcript. I want to see what that's going to look like, because that that thought has kind of occurred to me, I kind of want to try that. So instead of generating final timestamps, what we could do is, um, we could generate a bunch of these scores, and then I can download all those scores because the NLP tasks have all been done, or the LLM tasks have all been done in the cloud. And then I'll bring all of that data down locally. I'll download the data basically, and then I can plot the data. So I would probably need to write some sort of tool that's gonna that's gonna do this dynamic, analysis. Um, and then I can, yeah, I'll have to see how dynamic I wanna make the analysis thing. But I can write a tool that's gonna do the plotting, and based on that I can decide. So in that case, I'm not going to be looking at the what do you call it? I'm not going to be looking at the clips. I'm not going to be looking at the video itself. Rather, what I'm going to be looking at is the scores that each potential clip thing gets, and then I can select which ones I want clipped. Though now that I think about it, I think what my idea was previously was to just generate a bunch of clips, as in generate a bunch of timestamps. Basically, what I'm planning on doing now, generate a bunch of. Um, right now, what I'm saying is I'll generate a bunch of, you know, all the scores, and then I'll look at potential timestamps, and then I can mark the stuff. But then what I was planning on doing before was automate the process of generating those timestamps. And because there's so many different criterias involved, so there's probably going to be a bunch of different clips, a bunch of different potential clips. So there's going to be a bunch of noise, basically, is what I'm saying. Um, so then I would have to sift through the clips. That was what the original plan was. Uh, I think I might do that. I think you know what? I think I might do that. I think I might do that. I'll yeah, I'll still automate the process of, though, okay, I also want to export the NLP scores. I'll export the timestamps as well. Definitely. I'll export the timestamps, but I also want to export the NLP scores. Yeah, yeah. I want to export the NLP scores. Because, like, in the future, if I want to do something with this data, then, I could do something with it. Um, yeah, yeah. But okay, that's going to be it for today's stream. I'm gonna end here. Just a second. Hold on. Uh, yeah, yeah. That's gonna be it for today's stream. Wait, did we crash? It says we've only been going for 45 minutes. Did we crash? I don't think we did. Uh, yeah, no, that is odd. What time did I start streaming? Dude, it's not supposed to be 45 minutes. Why does it say 45 minutes, dude? Oh, it's not 45. It's 2 hours. Okay. It's 2 hours. We've been streaming for 2 hours and 9 minutes. I don't know why that said 45 minutes. That was probably some kind of glitch. Yeah, it's been 2 hours. Um okay, give me a second here. We are back up just a second. Okay. Uh yeah, let's go to this person. Okay, so let me start up the raid. Are we able to raid? Yes, we're able to raid. Okay, that's going to be it for today's stream. I'm going to carry on with this research because I need to think of more interesting ways to analyze the transcript and figure out, where interesting things are being spoken about and how to determine where a discussion starts and ends and stuff like that. So there's a bunch of things I need to discuss with Gemini, and hopefully Gemini can give me interesting solutions or even like viable solutions. I'm pretty sure using an LLM for this would be a lot better. It's just a matter of how do I pass in a chunk of information to the LLM aside from like just, bunching up a couple minutes worth of transcript into like one big blob of text and then feeding that in. That's not really going to give me, you know very granular information. But yeah, okay. Anyways, my timer is running out for the raid. That's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.